Okay, I think we'll get started now. So hopefully everybody's here for a session on virtualizing SQL Server. More accurately, this presentation should be titled Virtualizing Servers Running SQL Server, because I think that's more the focus of the session and really suits us in terms of how we can move from a scale-out physical environment to a consolidated virtualized environment. So to introduce myself, my name's Justin Langford, and I've worked for Coeo for almost 2 years now. And Coeo are a gold partner specializing in SQL Server, delivering consulting services and remote DBA. Prior to joining Coeo, I worked for Microsoft in their Premier Field Engineering team, and that meant that I was one of a number of engineers based in the UK working for Microsoft's Premier customers supporting SQL Server. So I spent 4 days per week on site with customers that dealt directly with Microsoft, and almost exclusively in the SQL Server area, these customers were finance or government-based customers. I've been involved in a couple of books contributing chapters around performance tuning and other bits and pieces. One from the Rocks professional series, the red books with the photos on the front for performance tuning in SQL Server 2005. And there's a new book being released in the beginning of January, which I contributed 4 chapters to. So Professional SQL Server 2008, Internals and Troubleshooting. And there were 6 authors listed across the bottom, and Christian's here. He just did a session on memory, and he has another session tomorrow. I'm doing a session today and a session tomorrow on consolidation. Brent Ozar, many of you will know from Quest, is here, and James Rowland Jones is one of the organisers of SQL Bits. So of those list of authors, almost all of them are speaking at this event, and very much looking forward to promoting the new book and hearing the feedback that we get. This book has got a slightly different focus from other books. There's a lot of books in the market which describe how SQL Server works, and that's great, but when you have a problem, there's not. It's very difficult to read an architecture or internals description book and convert that to troubleshooting steps. So the idea of this book was that it has some internals and architecture content, but it also has notes from the field type information where there's prescriptive guidance and instructions on using tools like Profiler, RML utilities, SQL Nexus to really gain visibility of what SQL Server's doing internally and how we can try and fix some problems. So the agenda for this session hopefully matches what your expectations are for this session. So we'll start by looking at the business and technical drivers. Why bother virtualize? It's a massive topic at the moment. Lots of people are talking about it. Those people that aren't talking about it feel as though they should be doing so, feel as though they should be kind of investing in this area and know what to virtualize and when to virtualize. We'll look at the goals of a virtualization project, what are the benefits to the business, how can we kind of sell this project to management in terms of what can they expect to receive from it, what are the common pitfalls, how can things go wrong with a virtualization project. We'll then think a little bit about planning a virtualization project and what's required when we're thinking about starting virtualization and how we can design this solution to be to support the requirements of SQL Server. In terms of design and implementation, we'll look at some options for designing virtualized solutions running SQL Server and also using virtualization to provide high availability for a server that wouldn't otherwise be highly available. And we'll finish with some issues and solutions and troubleshooting approaches for SQL Server when it's running in a virtualized server. So to start with, I just want to ensure that we're using the same language and we have a common understanding around what we understand by the term virtualization so that we can use these terms through the discussion and be consistent. So the problem is that over a period of time, enterprises organically grow and buy applications from vendors who insist that the application must have a dedicated SQL environment. Perhaps they have specific security or performance requirements which dictate that they must run in an isolated environment. And over a period of time, we get a proliferation of SQL servers each of which isn't doing a great deal. So the utilization of each of those boxes might be quite low, but we have quite a number of boxes. This means that we've got lots of servers which are underutilized. We have licensing requirements and maintenance requirements from a backup and restore perspective, from troubleshooting. We might have different builds, different standards that have been used in each of the servers. So they can become time-consuming to manage and expensive. The goal of a virtualization project is to provide server consolidation. So this means that we take a number of physical servers and we consolidate them to run on one physical server as logical machines. The software to run this is virtualized, so we host multiple virtual machines on one physical machine, and we're going to share those resources across the virtual machines that are running on it. The idea being that we get better resource utilization and we've got a more simplified environment to manage, so we reduce the support costs. So to kind of take an example where we have a number of SQL servers which are physical boxes, maybe running Windows Server 2003, SQL Server 2005, or any other boxes. We're going to take a new big box and install Windows Server 2008, and on top of that install a virtual machine manager or hypervisor. So virtual machine manager and hypervisor are terms which we can use interchangeably. We'll all be familiar with VMware and ESX or vSphere, the ESX offering here, which is the hypervisor layer. And within that, we can define virtual machines, and we can use a process called P2V, or physical to virtual. So there are tools available which we can run against a physical machine which generate or create VHDs, so virtual hard disk files of the physical server, and then we move that onto our consolidated virtual server. And as we do this across the estate, we see that the old machines are no longer required and everything's now running on our one big consolidated virtualized server. I want to compare virtualization to consolidation because the two terms are often used interchangeably but mean different things, and so that we're clear and in agreement on our understanding of what virtualization is and what consolidation is, I'll just describe consolidation briefly. So let's say today we have a server called Server 1 and it has an instance of SQL Server running on it, and that instance has a number of databases. And we multiply that across our estate, so we've got a number of servers with single instances hosting one or more databases. We can perform database consolidation, so that means that we take the databases off of SQL 2 on Server 2 and we're moving those databases onto Server 1. So at this phase of the project, we've reduced the number of servers by 1/3. Okay, so we don't require Server 2 anymore because the databases that were running on that machine are now running on the first machine. And then the next stage is SQL instance consolidation. So we can accommodate a number of SQL Server instances on any one physical machine. And this means that these coexist alongside each other. And at this point, we've reduced the number of machines to 1, although we have 2 instances of SQL Server running on it. That's clear? Everyone's kind of in agreement? Great. So I wanted to now just contrast the goals and objectives of a virtualization project and the same with a consolidation project. So the top half shows goals which are the same, and the bottom half shows characteristics, if you like, which are different. So both a virtualization project and a consolidation project has a goal to reduce the total number of physical servers in our estate. We want to reduce the number of boxes that we need to host our database platform. Both of the projects will have goals for savings on power, licensing and maintenance. And both of them will also have performance concerns because, of course, the business always says, you can do this project as long as we don't suffer from a performance problem. Where they differ is the second half, the lower half of the table, where we see that the virtualization project, at the end of the project, we're going to have the same number of operating systems. Okay, they're going to run on one big box as virtual machines, but from a service pack, backup and restore, maintenance perspective, we still have the same number of boxes to apply patches to. With consolidation, we're going to have fewer boxes, fewer servers at the end of the project. Therefore, there's less time and effort required to maintain those boxes. At the end of the virtualization project, we're going to have the same number of databases per instance and the same number of instances per server with a virtualization project, whereas the goal of the consolidation project is to to reduce the number of instances and increase the density of databases per instance. With the virtualization project, we're going to have no Windows upgrade, no SQL upgrade. We're almost going to pick up the box, virtualize it, and drop it onto a large machine where we're going to run it. So there's no change required there. We're just going to pick it up and drop it. With the consolidation project, we've got opportunity to undertake Windows upgrades and SQL upgrades at the same time. So you can see that there could be an opportunity there to combine these projects into an upgrade project. Virtualization has very much a black box approach. There isn't much knowledge required of the application's interaction with the database for a virtualization project, because we can pick the server up and virtualize it. It has the same name, same IP address, the logins are the same, the SQL agent jobs are all still there at the end of the project. Everything, for all intents and purposes, should be the same once the server is virtualized compared with when it's a physical machine. Contrast that with consolidation, and we have a much higher degree of engineering effort required to perform a consolidation project. In this situation, we need to know a fair amount about how to redirect the application from the old server to the new server once we've performed consolidation. We're going to need to move the logins across. We've got security to consider, any integration services packages, all that kind of stuff, linked servers. We need to know a fair bit about the application and the implementation to perform consolidation. Virtualization introduces an additional layer of technology, and that means that we require some skills in that area. So there's definitely a risk or opportunity there, depending which way we look at it, for VMware or Hyper-V or whichever technology we deploy, but there needs to be some knowledge in the organization of people that can design, implement and maintain virtualized solutions. With a consolidation project, we're not introducing any new technology because we're just repurposing and redesigning existing solutions. With virtualization, we've got hardware abstraction. So one of the benefits is that we can pick up a VHD, copy it from one brand server and run it on another brand server which has the same virtualization technology. So it's kind of quite interoperable and quite portable once we have a virtualized instance, whereas actually with SQL Server and Windows we have quite a tight hardware integration there. It's not quite so easy to move an instance of SQL Server from one place to another. So I guess what I'm saying is that consolidation and virtualization work well together, and there's definitely an opportunity when we're reviewing a SQL Server estate to consider the opportunities for consolidation and for virtualization. And it's really important that we know the primary goals of a consolidation project and the primary goals of a virtualization project, and how we can map those onto our organization and the project that we're trying to complete, to make sure that we stand a good chance of deploying the right solution to solve the problem. Okay, so this slide covers the business drivers, why virtualize, and we should consider virtualization as a form of consolidation because it's server consolidation. We can use virtualization to improve availability, and we can reduce costs. Now, a bit of kind of a caveat on reduced costs, because if we take our Windows Server 2003 machine running SQL Server 2005, I'll assume that it's properly licensed and Microsoft have been paid for Windows and SQL Server which runs on that machine. If we follow the P2V process of physical to virtual and create a virtual machine of that instance, and then we no longer require the old machine, but we haven't actually saved any money in terms of licensing because we'd already bought the copy of Windows which was running on that machine, and we'd already bought SQL Server for it. So we don't really save any money from a licensing perspective. However, once we've got the virtualized infrastructure deployed, I've got a slide on how the licensing works in a second, but we can, depending on which licensing alternative we go for, we can deploy future instances at no additional cost based on the licensing model. So we do realise some savings in terms of hardware maintenance, rack space and power, those kind of things. Obviously we're taking a server out of the rack so we don't need it there anymore, and we make some savings there. The virtualization management consoles have some really good resource utilization graphs and dashboards, which means that we can see a really good overview of the complete estate from one screen, which we wouldn't normally have from physical servers. And we've got a greener solution. We're using less electricity, so it's cheaper to run and require less cooling, so that also makes it cheaper. So all of these really add up to improved availability and reduced costs. What are the technical benefits of the virtualization solution? So we can benefit from hardware abstraction, because that means that we can port our virtual machines from one platform to another. We can get better hardware utilization. So I've got a picture of a nice Blade server, and this is quite a popular deployment method for customers that are looking for virtualized or consolidated servers. We also have very good mobility of virtual machines, so we can move them quite freely, and we'll talk a little bit later on about some of the high availability solutions in terms of live migration from Microsoft's Hyper-V and vMotion from the ESX or vSphere platform. So we can also use those technologies for high availability. And we've got this great technology where we can take a snap of a virtual machine, and we can completely clone a virtual machine and use that for our development or test environments. And when we restore that clone or that snapshot, we know that we have a machine which is absolutely identical to production as it was at midnight last night when the snapshot was taken. And it's actually quite difficult to do that with a physical machine. So it means that we can mitigate some risks when we're applying service packs, making changes and updates, that kind of thing. So the backup and restore aspect of virtualization does bring some benefits, really. There's a small note at the bottom. The ideal profile for a SQL Server workload for virtualization is not CPU intensive and not memory bound. I kind of think that that's, it's kind of, I'll qualify that in a minute, but I think that's the ideal workload for any DBA that's looking after a SQL Server, because everybody likes a server which has low memory requirements and not much memory, not much CPU. But those are really the candidates that we should be thinking about when we're kind of approaching a virtualization project. Okay, so what are the reasons that a virtualization project could go wrong? The first one really is that the goals are not well defined, that we don't really know what we're setting out to achieve with a virtualization project. The second one is really around a baseline that hasn't been taken, so we don't have a good understanding or clear visibility of the profile of workload of each of the servers within the estate, because not every server is a good candidate for virtualization, and we really need to define some qualifying criteria which say, okay, if a server meets these requirements, then we are going to virtualize it. However, if it's above this threshold or outside this range, then we're not going to touch it because of XYZ reasons. And certainly when we're undertaking these type of projects with customers, the first thing we're looking to do is build this criteria which say these servers are candidates for virtualization and these servers we're not going to touch for whatever reason. There's some arguments around, or some debates, I guess, around combining mixed workloads. So if we consider a transaction processing system and an analysis services system, they both have quite different I/O, memory and CPU profiles. And in some situations we can combine those because they're complementary, and in other situations it can be a complete disaster, and it's a bad idea to do that. And there are some pros and cons of each of those. So virtualization projects go wrong when we're virtualizing CPU or memory-intensive servers. So one of the big limitations of virtualization is that we can only present a maximum of 4 virtual CPUs to a guest virtual machine. Now, we can assign a virtual machine more memory, and we can try and improve the performance of the I/O path if we have memory or disk I/O problems, but we've always got a hard limit of 4 virtual CPUs, and it's very difficult, in fact impossible, to add more CPUs if the SQL Server is CPU bound at that point. So other reasons, they're kind of common points with any SQL Server project or new deployment. Insufficient testing is a good opportunity for failure, and suboptimal storage or virtual disk configuration. So we know that SQL Server performance is closely related to disk storage and proper disk configuration. And we should consider single points of failure, because in our beginning picture we have 4 or 100 physical machines, and we consolidate those onto a small number of bigger machines, and in our our beginning picture, if we lose one server, we impact one application or one department. And in our end situation, we run the risk that if we lose one physical server, we impact a much larger percentage of the business. So we should really be aware of what we're undertaking and what the options are to improve availability and remove the single points of failure. Okay, so we're planning a virtualization project. The process is really going to be to identify the goals or the return on investment objectives. So we want to consolidate 4 virtual machines into one, or 2 to 1. What's our ratio? What's our objective? And how are we going to design some kind of process which supports that? We're going to take an inventory of the estate and capture some kind of performance baseline. We want to know what the batch requests per second are, so this gives us a feel for the workload that SQL Server's running, and we want to get a feel for the memory, disk and CPU requirements of the server as it stands today. And we need to get a representative picture of the activity on the server, and that's going to lead us on to the next stage, which is really modeling application demands and requirements so that we can really build a feel for the requirements of each server in terms of hardware utilization. We need to develop a test strategy, and we can do some testing really quite nicely with virtual machines. So we can use this P2V process where we take an image, generate the image of the VHD of the machine, and we can boot that in a virtual machine and without connecting the network interface, and maybe change the IP address, and then we can do some testing before we do the live migration. And that means that we can really build confidence in the virtualization platform that we're stable and robust, and also that this application and database server is a good candidate for being virtualized. The next point is really start with low-hanging fruit. So we're trying to pick very underutilized servers, maybe with sympathetic user base, the IT department, help desk application, those kind of things are a good starting base, and really build the complexity and risk as the project matures and confidence builds in the platform. The final point is really that we should know the limits. So some organizations get carried away with this. They go, yeah, this virtualization technology is great, we're loving this, loads of performance, and we're getting really good savings on this, so let's virtualize everything. And that's really when things start going wrong, and we're virtualizing the wrong type of servers. We can impact the performance and availability of existing applications with this. Okay, so server modeling. So I always try and communicate this as a triangle. So if we start at the bottom, we have a large number of small applications. Most organizations are made up of some kind of hierarchy of applications with size and criticality in terms of the databases and the applications that they support. So at the bottom, we've got a large number of small applications, and these are low demand, low throughput. I call them peripheral applications. So they're around the edge of the business, supporting the business in what it does, but if they're down, we can still carry on, right? Nobody's going to die or anything. The next one is mid-sized applications. We have a smaller number of these, and these are mid-performance, and they're business critical. And by business critical, we mean that people aren't able to do their jobs when this application is not available, but we're not going to lose money. So, okay, somebody can't work for a day, they can't raise invoices for a day, something like that, but we're not going to lose money because the application is not available. And then at the top tier, we've got the large applications, and these are high performance, low latency, mission critical applications. So these are the ones that we really kind of lavish with attention and hardware and availability solutions, really to invest a lot of time and effort into managing these large applications. So hopefully, you can kind of relate some of the applications and servers in your estate to this model. And really what we're looking to do with the baseline is kind of map some applications to fill in these boxes in terms of seeing where these applications sit. And depending on the goals of the project and the ratios that we're trying to achieve, I would tend to say that we're going to look to virtualize all of the small applications, all of the small SQL Server boxes, and maybe some of the mid-size as well, depending on the impact, criticality, and requirements. Okay, so we mentioned some things about licensing already. So in terms of planning, this is one of the important things because on the return on investment, the ROI justification, the licensing is a really big piece when we can work out how quickly we can make back the money on the engineering effort and the hardware required to deploy a virtualized solution. So down the left-hand side of Windows Server 2008, we've got 3 editions, Standard Edition, Enterprise, and Titanium or Data Center. So Standard Edition supports one license, supports us for one host and one virtual machine. Enterprise Edition for one host and up to 4 virtual machines. And if we go to IA64, the Itanium platform or data center, we have one host and unlimited virtual machines. Of course, if we're taking a physical machine which already has a valid copy of Windows and going through the P2V process, we already have a license for that, so that's outside of these requirements. So this is really for new deployments that are going onto the virtualized platform. And some specifics around SQL Server 2005 or 2008. Standard Edition, we use per processor licensing, and Microsoft treat a VPU, a virtual processor, the same as a CPU, whereas with Enterprise Edition, we have no host limit and unlimited for virtual machines. So they're really building the case for using Enterprise Edition SQL Server in a virtualized platform. There was some changes to licensing announced at PAS a couple of weeks ago. I don't know how many of you kind of followed the output of that, but the licensing model for SQL Server 2008 R2 will be slightly different, and Enterprise Edition is capped at 8 CPU sockets, and the Data Center Edition is unlimited, so it kind of more closely reflects the Windows model. The next question, which is quite common, is will CSS, so the Microsoft customer support team, are they going to support my virtualized solution? And until recently, the answer was no, basically. So they would support it, but you had to reproduce the problem outside of a virtualized environment, which really meant that they didn't support it. This policy changed, and Microsoft announced this Server Virtualization Validation Program, SVVP, and it's on the Windows Server Catalog website, so anyone that's familiar with looking at failover clusters and that sort of thing will know this program and website. So basically this means that the solution has to be certified by the vendor, and then Microsoft will support it. And if there is a problem, a performance problem or anything else, then you can raise a case with Microsoft, and they will, if they believe it to be a virtualization issue, in turn they have an agreement with the virtualization software vendors, and they can raise a case with those guys and work together to find out what the problem is. Before this time, we were pretty much left on our own to fight the case between the two providers and try and get to the bottom of what the problem is. Okay, design and implementation. Many of the kind of recommendations that apply to a virtualization project apply to any SQL Server project, because there are lots of opportunities to go wrong, and it's no different with a virtualization project. So the first is proper hardware sizing is critical. So we need to identify which servers are not really good candidates for virtualization. And by this we mean if we've got a 32-way server with 64 gig of memory and the host for the virtual machines is the same, it's not going to be a good candidate for virtualization, because the host is not going to be able to support that virtual machine and other machines particularly well. So, knowing the limits and designing a system which is going to work well is kind of one of the prerequisites. Good storage configuration, it goes the same for any SQL Server project. SQL Server performance is closely related to storage. We've got a couple of specific recommendations around storage. So there are 3 different options when we're using virtualization for disk configuration. So fixed disks, pass-through disks, or dynamic disks. Dynamic disks expand synchronously. So as we require them to grow, they will grow on the storage level. It's pretty similar to auto-grow in a database for SQL Server, and we really see that as a safety net. We don't want to use auto-grow, and it's exactly the same with SQL Server and virtualization. We should avoid using dynamic disks, because we're going to pay the price when a user tries to do something and we run an index maintenance job. We're going to have to wait for the underlying system to extend the disk. So if we use fixed disks or pass-through, that means that we have pre-allocated space and we have no I/O delays in that situation. Some vendors also have this technology called thin provisioning, and this really means that you can present a LUN which is much bigger than the space which is actually allocated to the host. For example, you can present a 250 gigabyte LUN but only occupy 10% of that space on disk, and the remaining space will be allocated dynamically again. And that's a really good candidate that we want to avoid as well, because it sounds great, but it doesn't work particularly well for database environments. Configure MPIO. So MPIO is the multipath input-output, so the device drivers for the storage network, which means that we have control of the path and how the routes that the hosts take to the storage. So making sure that we have the right drivers there. There's a DSM, device-specific module, which must be installed depending on the vendor of the SAN. And once we have that, we have a really good chance that we're going to get good I/O throughput. And without that, we'll use a generic driver, the Microsoft MPIO driver, and performance is going to be less than optimal. The final point is tuning HBA queue depth. Is anyone familiar with this? Anyone undertaking HBA queue depth tuning? Okay, great. So HBA is the host bus adapter, which is basically the network card for the storage area network. So this is the card which sits in the back of the server with a fiber channel connection in it. That goes to our storage fabric, and then from the storage fabric into the controllers, which goes to the disks. The HBA has a queue length on it, and depending on the number of items which are in the queue, we can affect the throughput to the storage from the host. And this is a really good candidate for optimizing physical servers and virtual servers as well. So the typical value from most vendors, depending whether we're kind of Emulex or QLogic, tends to be 32. And there's a bunch of stuff on the web which you can do some research or do your own testing to identify what the optimal configuration is, and you can really increase the value of this. So I worked with a customer recently who had an HP EVA 8100, which is kind of this high with 125 disks in a storage array, and we got the HBA queue depth. When we doubled it, we almost doubled the throughput to the disks as well, and this is just by changing one parameter. So it's really important that we can really give the host much faster access to the storage by increasing this. Some important points to remember in terms of limitations. So we've got a hard limit of 4 virtual processors per guest. And for me, that really it's self-selecting in terms of the candidates that we can use for virtualization, because we can only use quite small servers for virtualization. We have a limit of 64 cores in the host and 64 gigabytes of memory in the host as well. There's some studies been done by Microsoft on Hyper-V, and also by VMware running SQL Server, and they actually compare x86 and x64 and show the benefits of 64-bit, and the 64-bit performance really justifies the extra hardware and effort for Windows, so it's really worth doing that. The final point is actually quite an important one as well. Avoid overcommitting CPU or memory. So this means that we can have 8 physical CPUs in the host machine, and we could have 4 virtual machines, each of which have 4 virtual CPUs as well. So we're overcommitting the resources between virtual machines to the physical CPUs. And that can really lead us to problems, because if we consider the query optimizer in SQL Server, it behaves as though it has exclusive access to 4 physical CPUs, when in reality it's sharing those CPUs with other virtual machines. And we can restrict the likelihood or limit the impact of that by not overcommitting the CPU or over assigning the memory to each of the virtual machines. So we ensure that we have a mapping of the total amount of available memory in the host machine, and that is divided among the virtual machines which are operating as well. So onto a topic which...
SQL's running on one of those virtual instances. It's only got the memory, so I'm not sure I understand the point you're making.
Okay, so if we have a machine with 8 gig of physical memory, right, we can assign 4 gig of physical memory to 4 machines, which means that we've effectively committed 16 gig of memory to those 4 gig to each of 4 virtual machines. But the host that's running...
Yeah,
so you can do it. The technology allows you to do it. Yeah, the technology allows you to do it, and it's one of those things where you can deploy 2, 3, 4 virtual machines and then create a couple of test virtual machines. One of those goes crazy, somebody issues a bad query, we get a bad plan cached, and it's going to swallow up all the memory and impact the other resources because the host is...
Can't do it even though...
Yeah, the technology allows you to do it, but yeah, it's a bad idea, basically. So one of the interesting points for me is really around, so we've got some great stuff around licensing, consolidation and virtualization, but is we can introduce high availability when we're introducing virtualization technology. So we can take our legacy machine, which is running really old hardware, Windows Server 2003, SQL Server 2005, and we go through this P2V process, and we can make it highly available. So we can have standard edition Windows, standard edition SQL Server, and introduce high availability in the virtualization layer. So we've got opportunity without much effort to improve availability of the entire server using this technology. So it's quite a nice situation. So VMware have a technology called vMotion. Is anyone familiar with this? How many people are using vMotion? A couple of people? Okay. So vMotion is the ESX technology which allows us to live move a server without dropping a ping from one physical host to another physical host. So it uses a technology which is very similar to that which is used by live migration, and live migration is the Hyper-V, which is the Microsoft offering in terms of this high availability solution. So live migration runs on Microsoft failover clustering, Windows failover clustering. So we install a failover cluster with 2 physical nodes, then we install Hyper-V as an application there, and using live migration we can, both technologies actually use the same thing, which is that they copy the pages in memory from one host to another host, and they initially take a snapshot, copy that across, and then keep synchronizing until both hosts are completely synchronized, and then bring up the virtual machine on the second physical machine. And that's how they support zero packet loss, zero ping loss from a high availability perspective. A couple of aspects to consider as the difference between vMotion and live migration with Hyper-V. Live migration runs on a failover cluster, so if we have a resource failure at any level in that cluster, we can use the failover cluster will fail over. vMotion is only intended for planned failovers. So it's great when we want to perform maintenance on one of the hosts, but vMotion isn't going to help us if there's a controller failure or the power supply blows up on the physical machine. It's not going to help us move that virtual machine from one to another. There are some other tools from VMware to help us in that situation, but we need to buy those separately as well. One of the drawbacks of live migration is it's a failover cluster, so we can only migrate one resource group at a time, so we can only move one virtual machine. Whereas with vMotion, we can move many virtual machines from one physical host to another. Although the time that it takes to do that is dependent on activity within the server at the time, because it's copying the pages in memory, so that if those pages are continually changing, it has a hard job keeping up with copying those pages across the network, basically. So we can also use virtualization for site resilience. So an extension of high availability is really using virtualization to mitigate against loss of a specific data center. So in this situation, we need to use some additional technology as well as virtualization. And we also need to use storage level replication. And storage level replication is normally the binding factor, if you like. This is kind of the thorn in the side of this solution, is that we need storage level replication. So EMC have a technology called SRDF, and asynchronous SRDF, and HP have a technology called continuous access, and I'm sure Hitachi and NetApp have similar solutions as well. And they're essentially block level replication for the storage between the two sites. So we have 2 SANs, one in each location, and configure block level replication. So we need pretty good round trip time on our network in order to ensure we don't get any latency at the primary site. But this solution in the diagram program was lifted from one of the Citrix white papers. So they use this technology called Essentials for Hyper-V. So we can make a Windows cluster, use storage level replication, and we can then live migrate a virtual machine from one site to another site. So I think that virtualization provides a quite attractive alternative to site availability in this situation. Okay, troubleshooting for virtualized servers. For all intents and purposes, we should approach a problem on a virtualized server exactly the same as we would on a physical server. So the tools that we're going to use to tackle the problem are going to be the same. We're going to use Perfmon, Profiler, and we're going to start with some kind of methodology for approaching this problem where we look for resource bottlenecks, and we're going to look at CPU, memory, disk, network, and try and identify one of those resources as being the problem or eliminate them from the situation. And at this point, if we've eliminated all of the hardware resources from being the cause of the problem, we then look for resource depletion. And kind of by resource depletion, I mean the worker threads in SQL Server, TempDB, blocking, that kind of thing, locking and latching. So we really have visibility of what the behavior is and performance is on the server at the time. The only exception to this is CPU counters, because the CPU counters, when we're running Perfmon in a virtual machine, can be different. And this is because of the way that the virtual CPU is presented from the host machine to the virtual machine. It means that the tick count, i.e. the clock time that we get from each of those CPUs, might be slightly adrift between virtual CPUs. And that means that the duration that we get when we're running queries and Perfmon counters can be inaccurate. So most vendors provide tools for monitoring CPU performance on the hypervisor layer, and you get counters added for the virtual machines, so you can monitor the CPU consumption of each of the virtual machines, but you must do that in the hypervisor, not in the actual virtual machine itself. So interesting reads. I've got a couple of links to white papers here. There's one from the SQL Cat team, and they published a white paper which reviews the performance of a SQL Server instance and a set workload when running on a single server, when running with a native instance of SQL on there. They ran a workload, they ran dbcc checkdb, backed up a database, restored a database, and took a Perfmon capture of CPU, memory, and disk time during that workload. Then they installed Hyper-V, a virtual machine, restored the database and did exactly the same tests and monitored all of the stats. And then they installed multiple virtual machines and did the same tests each time to kind of try and get visibility of the effect, the overhead that is introduced by the virtualization, by the hypervisor layer. And that makes quite interesting reading, and the conclusion is that the overhead is quite low, and it's more CPU overhead than anything else. So it's 10% or less for CPU, but I mean, take a look through the white paper, and they compare the 32-bit and 64-bit as well, and you can get some feel for the numbers in terms of what kind of overhead we're going to introduce by taking a physical machine and virtualizing it. The final reference is a very similar paper, but it's written by VMware and kind of talks about best practices, deployments, performance overheads, optimizations, and that kind of thing for running SQL Server 2005, I think, in a VMware environment, but most of those best practices will apply. Okay, so I've gone through quite quickly, actually. You'll be pleased. So in summary, virtualization can provide significant savings. We should test thoroughly, and we should start with low-hanging, low-risk fruit to kind of gain confidence in the platform and in the process. We can combine this project with a SQL consolidation, so looking to actually reduce the number of servers that we're running and increase the number of databases or instances per server as well. And we should also look at high availability options.